Hi, my name is Peter Curing. I'm the co-CEO at Whirlitone. Whirlitone has been in business since 1965, and we're a premier supplier of high-power components to the RF industry. We have several of our products here today to display at the IMS show here in 2024. We can start over here with our quadrature hybrids. This is the first stage of our combining, where we're combining at the transistor level with wideband components, and then from the transistor level, we then move into the coaxial components, where we'll take multiple transistors and combine them to the next higher power level. After that, we move on to a product line that we are very successful with. These are radial combiners. They're well known in the industry. We supply them with wide frequency bands and in a variety of different structures, from SMAs to end connectors, and we have several others at various frequency bands that start out with a coaxial 7/16 connector, and they could go to a waveguide output or they could go to a coaxial output. These are designed for radar applications, and then we go to higher power with ends, and then we'll eventually end up with EIA outputs as we go into the multi-kilowatt range. In the last couple of years, Whirlitone has expanded into waveguide products as well. That includes our E-plane structures shown here, Magic Tees, waveguide directional couplers, and high-power isolators and circulators as we work with partners. This is a purely waveguide structure. It's our E-plane combiner. This is a small C-band component which takes 8 waveguide inputs and combines it to a waveguide output at C-band. Very novel planar design. In previous times, you had to take a radial combiner structure, which was very bulky, and combine it to an output. We've now converted that into a planar structure. It does two things. It allows us to put it in a rack-mounted solution, and it also allows us to go to much higher power levels. The power level of any of our E-plane combiners at the sum port is determined by the size of the output waveguide connector. This is an X-band structure where we're combining 16 9 to 11 amplifiers, solid-state amplifiers. Whirlitone is now designing precision coax to waveguide adapters so that we're not losing any loss in the entire structure. So from this point to this point, we're about 0.15 dB of loss, which is very low, to get to a multi-kilowatt output port at X-band. So 16 coax to waveguide transitions through the E-plane to a final output. Our next product line that we're just moving into now is a combiner directional coupler combination, which allows us to cover the full 2 to 18 gigahertz band in one shot. Currently out in the marketplace, it's 2 to 8, or 2 to 6, and then 6 to 18. We afford the customer the ability now to do a full 2 to 18 combining architecture in one shot. This is a 200-watt combiner combining 4 2 to 18 amplifier modules. At the output, we also want to be able to measure that output and ensure that it's actually there. So our new design for a full 2 to 18 dual directional coupler for a 200-watt power level range. So why did we initiate this R&D effort for a full 2 to 18 band? In the EW field, 2 to 18 in one shot is very valuable to our customer because they don't have to break this band up into 2 different amplifiers. So these two components allow us to take 4 modules, full 2 to 18, and put it into one amplifier. That is a size savings for a customer that is looking to put this into a platform that needs to cover the full 2 to 18 band rather than having 2 separate amplifiers covering that full band. So although the cost might be a little bit higher by putting this all into one with today's technology, in the future, as GaN technology improves, the cost of this amplifier will go down and we'll have it all in one shot. So we're pioneering this product to the marketplace now, and it's very well received by our military customers. So as we go higher in power level and we improve the swap of all of these devices, we're finding that the warfighter, in a much more challenging electronic warfare environment, is giving our customers options to reduce size and weight of their platforms so that we can push antenna development, we can push combining architectures, and we can push the overall amplifier systems to a much smaller package. That's our goal, is to get higher efficiencies, maintain the higher efficiencies that we're known for at much wider bandwidths while cramming it into a smaller box. So as Whirlitone moves higher in power and wider in frequency, we challenge the industry to bring us your hardest requirements. We always say at the office that we swim in the deep end of the swimming pool. Bring us your challenges so that we can address your most difficult needs. Thank you.